Welcome back, everyone. We're going to be solving LeetCode 1694, reformat phone number. So we're given a phone number as a string, and it consists of digits, spaces, and or dashes. They want us to reformat the phone number in a certain manner. First, we have to remove all the spaces and dashes. Then they want us to group the digits from left to right into blocks of length 3 until there are 4 or fewer digits, and we need to use these constraints if there are 4 or fewer digits. The blocks are then joined by dashes. Notice that the reformatting process should never produce any blocks of length 1, at most blocks of length 2, and then they want us to return the phone number after formatting. So if we look at our examples, we've got this phone string, and then we've got the return output separated, our numbers separated into blocks of 3 with a dash in between. Okay, so just a forewarning, this is going to be, I'm going to write a longer version of this, but it's more intuitive than some of the other solutions that are in the solutions tab over here. So what I'm going to do is, first I'm going to create an array. We'll just call it array, and what is going to be inside of this array? Well, the first thing we need to do is just grab all of the numbers, right? We don't want the dashes or the spaces in here, so we can do a list comprehension and say we're going to grab every character for character in our number string if that character is in the range of 0 to 10, non-inclusive. What would be a good way of checking that? Well, we can create a set. Let's call it S, and it'll be set. What is going to be in this set? Well, it's going to be the string representation of the number for number in range 0 to 10, non-inclusive. So by doing this, by creating a set with these numbers, this will give us an O of 1 lookup time, and we don't have to check for inequality, right? So we don't have to, in this list comprehension, we won't have to say, only grab the number if it's not equal to a dash or a space. It's subtle, but checking in a set gives us an O of 1 lookup time. So it's going to be slightly faster than just checking for inequality. So that's why I'm using a set here. Again, it really wouldn't matter. You could do the if statements to check for the dashes and the spaces if you wanted to. That's just not what I'm going to do. So we've got every character for character and number if that character is in our set. Okay, so let's print this out. Let's see what we have. We'll print out our array, and we should have the representation of all of our digits that we're going to be working with. Okay, so now what do we need to do? Now we need to handle the case where maybe we have an input number of only length 4, 3, or 2. So we're going to handle these cases first, right? So we can say if the length of our array, if that is equal to 4, and why am I saying the length of array here? Because we've grabbed all of the digit representations of our phone number and placed them in here, right? So if we had an input string of length 4, right, we had 1, 2, 3, and then a dash, we wouldn't have 4 digits, so we have to check for the number of digits we have. So we'll say if the length of array is equal to 4, what are we going to do? Well, we are going to, we'll have another array, we'll call it res, our resulting array. What are we going to do? We're going to run into every character, and we are going to do exactly what this says. Append 2 of the characters and separate them by a dash, and then append 2 more, right? That'll give us length 4. So we'll say res.append array. Now, how are we going to get these digits? Well, we're going to have a pointer so we can keep track of where exactly we are at inside of this array without using a for loop. So we'll say array or result.append array at our pointer position, and then we'll do it again and again and again. Now, they want it in blocks of 2 if it's 4 digits, right? So here we will append our separator, which is a dash. Okay, so if we're working with a pointer, we have to increment it every time we use it. So we will also have to do that. Pointer plus equals 1 here. Same thing here and here. Right, so this will allow us to, again, keep track of where we're at in our array, so we grab the correct digits. Okay, so we've handled the case for 4. Let's check the case for 3. So 3, they just want a single block of length 3. So we can take this, do the same thing. So we'll append 1, increment a pointer by 1, append another, increment our pointer by 1, and then increment the third one. Now let's check for the last case, which is just 2. If it's equal to 2, what do? Well, we just simply do the same thing. Append 1, increase our pointer, and then append the final one. So, alright, now we have handled our conditionals here for when we have an input string of 4 or fewer. So what do we need to do now? Well, now we can handle just our regular cases, right? So say we have this as our example, this needs to be our output. So it's going to be something similar to what we just did, but we're going to say while our pointer is less than the length of our array minus 4. Why do I say minus 4? Because when there are 4 or fewer digits left to be working with, right, this is what we're going to follow off of. So what we're going to do is just grab the blocks of 3 and then append them into our resulting array and separate them accordingly. And then after we reach the end where we only have 4 left, that's where our conditionals come in. So how do we grab the blocks of 3 in an array? Well, we can simply say for num in range of, actually for num in the slice, what did we call it up here? We called it array. Array slicing, starting at our pointer position and going up to our pointer plus 3. So why do I say this? So say we have this as our array, right? 1, 2, 3, 4, 5, 6. We're going to start at 0, which is where our pointer's at, and we are going to go all the way up to 3, but not including 3, right? So we'll go 0, 1, 2, 3, right? So this is the cutoff. This is the block. This is how we get the block. What are we going to do with all of these numbers inside of this block of 3? Well, we're simply just going to append them to our resulting array. Res.append that number. So what do we do after we have appended this block of 3, right? Well, since we're going up to the pointer plus 3, we're going to have to increase our pointer by 3, so we can run this loop again and then grab the next block of 3. And then at the end, what we'll do is we will append our separator, right? Because we could still have items after we get all of the blocks of 3. So we're going to need this separator, and actually we will have. So after this runs, we've got our blocks of 3. Now what do we need to do? Now we need to have our conditionals, right? So our pointer will be pointing at 4 from the end. So we'll have to say if, what do we want to do here? We want to grab those. So if our pointer is equal to the length of our array minus 4, what are we going to do? We will do res.append the array at our pointer position, and we will do that again and again and again, and this will be separated by a dash, and we have to increment our pointer by 1 each time. So elif pointer is equal to length of array minus 3, and then minus 2. Length of array minus 3. Put a space here, easier to read. Do the same thing. One, 2, 3, increment it. And our last case, length of array minus 2, then it will be just append the last 2 items. Okay, so this should give us our result. So let's run through this. We've got this array. We'll come here, grab these 3, append that, grab these 3. Okay, so what do we need to return? We should have, let's print out our res, get rid of some space. Okay, so this does give us the correct output for test case 1. What about 2? We've got 1, 2, 3, a dash, 4, 5, another dash, 6, 7, and then case 3, we've got 1, 2, 3, dash, 4, 5, 6, dash, 7, 8. So we do pass all the test cases, we just need to return the string join of our array. So if we, not of our array, of the resulting array. So this should give us the correct answer. We pass all 3 test cases, and it does run. So now this is, like I said, is definitely a lot longer than some of the other solutions you're going to see, but I think it's more intuitive to think about it this way. And so let's talk about the runtimes, right? So the runtimes are going to be, we're creating a set with a for loop, so this is automatically going to be O of n, right? Same thing here, this is going to be O of n. We're creating a new data structure, and we're using a for loop to do it. Now, this is all going to be O of 1. These are all constant time operations. Same with these here. This, however, you might be, you might want to say that it's O of n squared, right? Because we have a for loop, a nested for loop inside of a while loop. But that's not that won't be O of n squared. Why? Because this is always constant. We're always checking 4 from the end of our array. So we're not doing an O of n squared operation here. This loop is actually O of n. So, and then, like I said, the rest of these are O of 1 constant time operations. So what does that give us? That gives us O of n plus O of n plus O of n, which can simplify it down to just a O of n runtime. Now the space complexity obviously isn't going to be the greatest, right? We're creating 3 extra data structures here. We've got a set, we've got an array with just our numbers in it, and we have a resulting array that we will eventually use for our string join. So the length of our or the space complexity of this problem will be the length of all 3 of these added together. So it'll be O of our set length plus our array length plus our resulting array length. Okay, that'll do it for LeetCode 1694 reformat phone number. Let me know what you think in the comments.